Hi Sarah, so I'm gallivanting over the world, all over the world again. I'm actually with my wife in Jamaica. We're coming up on our 1 year anniversary, so we had scheduled a little uh, sort of anniversary trip before I even started working for Flex School. So we're kind of locked in on that, but obviously I don't want things to suffer with your studies, so I wanted to create a little video lesson going over the stuff that we would have went over today on Monday. So we left off right when we were talking about this whole 3D thing, and we talked about how you were having trouble with that. And so I'd given you this as an assignment to work on to try to finish this, but I wanted to basically go through it so just you can check your work and see if you got the same thing. So right, we have our little prism here, and the key thing is getting the dimensions right. We need what to find the volume of, to find the surface area. We need to find the area of the two faces in the front, the rectangle in the back here at the base, and the rectangle in the front. So we need to get all those dimensions. So why don't we start off with the two triangular faces, right? So we need what to find the area. We just need the base and the height. So yeah, we need to find that base and the height. So let's put this together, right? So let's focus on this base first. So what do we need to find this base here? Well, let's look at the points, right? What is this point right here? This is on the z-axis, right? Notice we're not anywhere on the x, we're not anywhere up on the y, we're just straight out on the z. So this is the 0, 0, 9 point, right? That's what's right here. Well, this is the exact same point right here, except for what's the difference? It came out on the x a little bit. So it should be 0, 0, 9, except for the x shouldn't be 0. Which point was that? 5, 0, 9. Right? Because as you can see, this guy came out a little bit on the x. That's the 5 units, right? So that being said, the only difference between here and here is the fact that it came out 5 units on the x. So we know that this length is 5 right here. What about this height? Right, we got the base of the triangle. What about the height? Well, what's this point? Well, it's still the same as 0, 0, 9, except for it went up on the y. So the y will not be a 0. Which point looks like that? 0, 2, 9. So that's this point right here. Well, what's the difference? Instead of being 0, 0, 9, it went up 2, so we know that this distance here is 2. So, right, for the front and back, we have the base and the height, right? So if we're trying to find the surface area, right, for the, let's call this the front and the back, and so we know that we need to do 2 times what? The area of the front and the back, which is 1/2, and what's the base? 5, and the height is 2. Awesome. So you got that part covered. Plus, what's going to be our next part? Well, we need to find for this top face here, what's this length, right? So we probably need to try to figure out, okay, well, we know this is, what is this here? This is 0, 0, right? And this length is going to be the same as this length. So if we find one, we find both of them. Well, if that's 0, 0, 0 at the middle, and we came all the way out 9, we know that this length here is 9. Going front and back here. So this length is also 9. Well, we know that, but what's this diagonal length here? Because, right, we need that to find the area of the rectangle. We need length times width. So what is this length going here? Well, let's try to figure that out. That might be a little bit more tricky, right? So we probably need, it's the same as the length and the height here. So, right, the distance between these 2 points is the same as the distance between these two. And the nice thing is we actually know what these points are, right? 0, 2, 9 and 5, 0, 9. So how are we going to go ahead and find that distance? Well, I'll tell you a smarter way of doing it. Instead of doing the distance formula, we already have this right triangle. You can see that. And what do we know about that right triangle? We know it's A and it's B. So how do we find C? A squared plus B squared is C squared. So 2 squared is 4. 5 squared is 25 equals c squared, right? So 4 and 25 is 29, so c is just the square root of 29. And I have a good feeling you kept up with all that pretty easily. So we have that this distance here is the square root of 29. I'm not even going to turn it into a decimal. I'm just going to keep it nice and neat at the square root of 29. Cool. So what can we do with that? Well, now we have the base and the base and the height for this rectangle, length or width, whatever you want to call them. So the area of that is just going to be what? Length times width, 9 times root 29. Okay, good. Now what about this rectangle in the back here? Alright, what is this guy? Well, we know the length is 9 and we know the height is 2, so the area of this rectangle is just 2 times 9, which is 18. Good. So now we have the rectangle on the front here, the rectangle in the back. What about the rectangle at the base? Well, that's just 5 times 9. So what do we cover? We have front, back, bottom, and the two faces. This is the entire surface area. We just need to add these things together to get our answer. So what do we get? Well, 2 times a half just cancels out. We get 5 times 2 is 10. So this all equals 10 plus 9 root 29 plus 18, right? 2 times 9 plus 45. Add up all those numbers, right? 10, 18, and 45 is 73, I believe. So we have 73 plus 9 root 29. And that would be the surface area of that whole awkward looking shape there. So hopefully that makes sense. Like I said, it was a bit of a challenge. There's a lot of work involved to kind of trace all that out, but definitely doable. I'm going to clear this out in case you're still working on it. I don't want to have all these random numbers when you come back to look at it, but that's sort of the breakdown, and you can pause the video if you need to study that. But I want you to go through on your own from scratch and actually be able to fill this out, because it's important to be able to trace through these things on your own, especially if this whole spatial reasoning thing is something that gives you trouble. And as a person who has trouble with it, I know that it's really helpful to go through and do things like this, these sorts of little exercises, because they are annoying, but they make you better. And ultimately that's the goal, right? Cool, so let me try to fill back in what I had here. Good. So you have yeah, it looks pretty much like what it was before. Good. Awesome. You also were supposed to do number 34. I'm not sure if you did that one. Oh no, you circled it. Okay, so good. You're saying that one, and that's correct. Good. Okay, Sarah, so this next section is going to be about the surface area of pyramids and cones. So what they just have here, they're showing you, you have regular pyramids, you have non-regular pyramids. We're not really going to deal with non-regular pyramids because, to tell you the truth, their faces are all jacked up. They're all kind of twisted and slanted. It looks crazy. It's more work than it's worth. The regular pyramids have some nice patterns that we can use to write neat formulas. So let's say we take a pyramid like this, right? A nice square pyramid. If we take those triangles and basically fold them out, you'll get this picture right here, and you'll notice that we'll have 4 triangles that make the faces, and that what about the unshaded region? It's 1, 2, 3, half, half, 4 triangles that make the unshaded. In total, you see that this rectangular shape that we make here, half of it is shaded in. So the area of the faces, right, the lateral area, is just half of the area of this rectangle. Well, what's the area of the rectangle? Well, if you add up all the bases, they get this thing they call the perimeter, right, which is just basically adding up all the way around the base of the pyramid, right? So we have the perimeter there. and that's just equal to 4 times the side lengths because it's a 4-sided thing. If it's 5-sided, it's going to be 5 times the side lengths. 6-sided, 6 times the side lengths, etc. And then the height is just this slant height. They call it the slant height, right? It's like this little tilted altitude, and they just call that L, or the lateral slant height. So the area of this rectangle is just what? Base times height, so perimeter, right? Perimeter times height, P times L, but it's only half of that, so it's 1/2 PL. And you'll see that that's the formula right here. The lateral surface area, they call it L, is equal to 1/2 times the perimeter, which is adding up however many sides around, times the slant height L. And that's how you do that. And if you want the whole surface area, you just need to add in the area of the base at the bottom. That's what that B is. So you can read over this just to, feel clear, but that's the gist of it. Going over here, we have this section on a cone, right? And so cones have slant heights as well. They also have this vertical height down the middle. They call it the altitude. And then you have your base and your axis and whatnot. Cool. So how do we do cones? Well, the lateral surface area is just pi times the radius times the slant height L, which is basically, a height along the top of the cone down to something on the perimeter of the circle at the bottom. And that formula is pretty straightforward. And if you want to have the total surface area, you take this L plus the base, which is just a circle. So what's the area of a circle? Pi r squared. So you have your pi rl plus pi r squared. And I know you got that by now. So again, you can read up for some more details on what's happening here. Go through the examples just to get comfortable with the process if you get confused. And then here, the last part is about changing the dimensions. So what happens when you take the main dimensions, which are the radius and the slant height, and you change them? Say you triple all of them. Well, they'll show you that originally for this cone, you got a surface area of 24 pi. When you tripled this thing, right, it went to 9, and 3 went to 9. The total effect was you didn't triple the surface area, you actually multiplied it by 9. Why is that? Well, these things are just one dimension. So if you increase one dimension times 3, the surface area gets increased by 3 squared, which is times 9. So you actually don't have to calculate all that to figure that out, right? Just keeping track of how many dimensions, the effect is going to propagate through the dimensions. So tripling is times 3 for lengths, but for areas it's going to be times 3 squared. So you look down here and they ask you what's the effect on the surface area of this pyramid if you multiply the base edge and the slant height by 2/3. Well, you know it's going to be times 2/3 squared, which is times 4 over 9. That's going to be the effect on the surface area. You don't have to go through all the motions, but it's good to do the calculation once just to see how it works out. Okay, so what I did was selected these 2 examples. I want you to work through those because you're also going to have to deal with composite figures, right? Cone on top of the cylinder. We already talked about how to deal with this. You need to find the lateral surface area of the cone. Don't worry about the base here because it's not visible, so that's not part of the lateral surface area or the total surface area. So you take the lateral area of the cone, you take the lateral surface area of the cylinder, right? So we got the cone, the cylinder, and then you just need to take the base of the cylinder on the bottom, and then you have the total surface area. And they go through and kind of plot it out, show you how to add it all up, right? The cone's lateral area, like I showed you, the cylinder's lateral area, and then the base area, and then you fully, get the entire surface area. So go through that example, just to feel comfortable. Same, this is another great little practice example with a real life scenario. And then for during class, I want you to calculate these guys: number 2, number 5, number 8, number 9, number 10, number 11. 21 and 22 are a challenge. 33 and 34 are a challenge, and then number 17. So I try not to give you a whole bunch of problems.